All right, let's talk about JavaScript. If you've ever spent any time with it, you know it can be this incredible tool for creativity. And let's be honest, sometimes it's a source of pure frustration. Today, we're going to look at how to get away from those common coding nightmares and actually find the joy in it, pulling some great ideas from the book, The Joy of JavaScript. Let's kick things off with a feeling that I bet is pretty familiar to a lot of you. So, does this look familiar? You're deep in a project, staring at code that you wrote, maybe just last week, and it already feels like a tangled, confusing mess. You try to fix one little bug, and you just get pulled deeper and deeper into this maze you accidentally built for yourself. Yeah, pretty much every developer has been there. And there's actually a name for one of the most famous of these traps. You look at your code editor and you just see this pyramid of functions, all nested inside each other, trailing off to the right. If you're seeing that, well, you might just be in callback hell. It's a classic developer pain point. But the good news is, there is a way out. So how did we even end up in a place like callback hell? Well, these nightmares aren't just the result of bad habits. They're actually symptoms of a language that had to grow up incredibly fast to keep pace with the web itself. It had some serious growing pains. It's kinda hard to believe now, but from around 2009 all the way to 2015, JavaScript was pretty much frozen. It was stuck at version ES5. Now, in the tech world, 6 years is an eternity. The web was becoming more and more complex, apps were getting bigger, but the language itself just wasn't evolving. So developers had to invent all these complicated workarounds just to get their jobs done, and that's what led directly to some of these nightmares. And that brings us to the first huge challenge, dealing with asynchronous code. You know, anything that doesn't happen instantly, fetching some data, waiting for a user to click something, reading a file from the disk. In the early days, JavaScript handled all this with callbacks, and that's where the trouble really began. And this quote from The Joy of JavaScript just nails it. The solution that came along was a total game changer: promises. A promise is basically an object that says, hey, I'm working on it, and I promise I'll have a result for you, eventually. So instead of nesting functions, you just chain them together. It flattens the whole thing out. And wow, this slide just says it all, doesn't it? On the left, that's the infamous Pyramid of Doom. It's hard to read, it's hard to follow, and it is a real pain to debug. But look at the right. With promises, the logic is totally linear. It reads like a simple story: do this, then do this, then do that. It's the same exact logic, but it's just so much cleaner and easier to manage. Okay, so promises helped us clean up the logic inside our code. But what about organizing the code itself? I mean, how do you stop a dozen different script files from just colliding with each other in a big app? In the early days, it was pure chaos. Every single script you loaded onto a web page shared one giant global space. So if your code had a variable called user and you used a library that also had a variable called user, well, whoever loaded last would win. This led to these bizarre, impossible to track down bugs. It made building big applications a real gamble. You can really see the community scrambling to solve this problem on this timeline. First, back in 2009, Node.js comes along with its own system, CommonJS, for the server. But that didn't really work in browsers, so then AMD was invented. Then UMD showed up to try and make those two play nice together. It was a messy but really creative time, all building up to 2015 when we finally got an official standard solution for everyone: ECMAScript modules, or ESM. And here's what that looks like. You've got CommonJS on the left, using require. On the right, you have ES modules with the import keyword. Now, this might just look like a syntax difference, but the really important part is that import is static. That means tools can analyze your code before it even runs to see what you need. And that enables incredible optimizations like tree shaking, where your bundler can literally shake out any code you didn't import, making your final app way smaller and faster. It's a massive win. So we've tamed our async code. We've organized our files into modules. Now let's talk about a powerful shift in mindset, a new way of thinking that helps manage complexity right at the source, thinking in pure functions. So what is a pure function? Well, the definition is pretty simple. It's a function that acts like a perfect little machine. For any given input, it will always return the same exact output. And crucially, it doesn't change anything outside of itself. No hidden surprises, no side effects. It's predictable, it's testable, it's totally reliable. I absolutely love this metaphor from the book. Each pure function is like a self-contained Lego brick. It has a specific job, a specific shape, and you can snap them together with confidence to build really complex things, because you know that one brick isn't going to magically change the color or shape of the one right next to it. And this slide makes the difference so clear. The function on the left is impure. See how it reaches outside of itself to change that total variable? That's a side effect. Its result depends on the entire history of the program. But the pure function on the right, it's completely self-sufficient. All it cares about are the inputs you give it right now. That makes it way more robust and so much easier to understand. Now, escaping these nightmares isn't a one-and-done kind of deal. The language itself is constantly getting better, and thankfully, there's a very careful, open process in place now to make sure we don't end up in another 6-year freeze. This is it. This is the roadmap that a committee called TC39 uses for every new feature. An idea has to survive this whole process from a simple straw man pitch all the way to finished. What this means for us as developers is that the language evolves in a stable, predictable way. No more sudden, breaking changes out of the blue. We can literally watch the future of the language get built. And that process is already working on some really exciting stuff. The pipeline operator, for instance, could make chaining functions together even more readable. Decorators are coming, which will give us a really elegant way to add behavior to our classes. And the big one, there's always talk about a static type system, which could help us catch a whole class of bugs before our code even runs. The journey toward a more joyful JavaScript is definitely not over. So here's the big takeaway from all of this. JavaScript isn't a static target. It's a living, breathing language that's constantly improving. The patterns that gave us nightmares yesterday have been solved with elegant solutions today, and even better ideas are just over the horizon. So the real question isn't just what the language will do next, it's how will you continue to learn and evolve right along with it.